Okay, in this example, we're going to continue looking for asymptotes, and I want to remind you to look back at the video where I go over the basis for all the methods I'm applying here. I've explained where those come from in a previous video, so I'm assuming you've already looked at that, and so I can proceed with you knowing some basics about rational functions and their asymptotes. So it says, give the equations of any vertical, horizontal, or oblique asymptotes for the graph of the rational function. So I want to first see if I can factor my numerator or my denominator, but actually not the first thing I want to do. In this form, it's actually useful to determine whether I have a horizontal asymptote or an oblique asymptote. So before I get to factoring, I'm going to first determine that. So I actually have two polynomials, the numerator and the denominator, have the same degree, which means that there will be a horizontal asymptote and that it'll be y equals a constant, and the constant will be the ratio of the lead coefficients. So the lead coefficient on the top is 1, lead coefficient on the bottom is 2, so I have a horizontal asymptote at y equals positive 1/2. So that part's done. The oblique asymptote is not going to happen because you either have horizontal or you have oblique. You won't have both. So there is no oblique. So the last thing we need to do is figure out vertical asymptotes. And that would be any x values that would cause 0 in the denominator. So I'm going to take the denominator and see if I can solve it when I set it equal to 0. So let's see if this factors. The AC method would give me -20 as a product. The middle is a sum of -1. So I can get that to happen with -5 times 4 and -5 plus 4. So I'll leave the two end terms alone and rewrite my middle term as 4x and -5x. Then I can factor by grouping, factoring out a 2x from my first pair. So I have 2x times x plus 2 and -5 times x plus 2. And then I have this common factor, so I can factor that out, x plus 2 times 2x minus 5. And so if I set each one of these equal to 0 and solve for x, I'll get x equals -2 and positive 5/2, which means that I have vertical asymptotes at those values, because those would be the ones that the function would not be able to cross. All right, so those are my final answers there, -2 and 5/2. Number 12, same directions. Let's see, we have again the same degree. So there will be a horizontal asymptote at the coefficients 2/1. And that means there's no oblique asymptote. And then the vertical asymptote will happen wherever the denominator is 0. So I'm going to take x squared plus 6, set it equal to 0. Okay, well, this leads to x equals plus or minus the square root of -6, which is plus or minus I times the square root of 6. So this is actually not real. Oopsie. This is not real or non-real. which means it wouldn't show up anywhere on the XY plane. So that means there are no vertical asymptotes. Let me see how we're doing with time here so these don't get too long. Yeah, I'll stop it. Why not? I think it's good.